Lesson 7.8 is a little bit out of order, but today's is going to be real short and sweet. Um, so the reason I'm doing 7.8 before you move into the earlier lessons is there's a strategy that the book doesn't show you that I like to teach because it follows a much more step-by-step process. The book wants you to do some guess and check this unit. I don't want you to guess and check because there's a better way. Um, so we're going to start with factoring by grouping. There's more to lesson 7.8, but we're going to kind of use that as a review at the end of the chapter. So factoring by grouping is useful when we have something like this. There are 4 terms. Later in the unit, we're going to force this to happen so we can use this strategy. But right now, the only thing you know how to factor is factoring out the greatest common factor. There's a different type of factoring where you break the coefficients down into their factors. Um, it's kind of confusing to explain now, but once we understand this, it'll kind of put everything together for us. So factoring by grouping has 3 basic steps. Step 1 is to group terms into pairs, hence factoring by grouping. So what we mean by show this with parentheses is I'm going to take the first 2 terms and the second 2 terms. Notice I include the plus sign. Sometimes there'll be a minus sign there, and it's also important to include that. So I grouped terms into pairs. Step 2 now is to factor the greatest common factor out of each binomial. So if I look up here, what's the greatest common factor in this parentheses? Well, the number in front of x cubed is a 1. I can't divide anything out of 1, so there's no number part to divide. But this one has 3 x's and this one has 2 x's. I can take 2 x's out. Remember, I can always take out enough of a variable so that one just runs out. So this one will have an x left, but this one's going to run out if I take 2 x's away. The other parentheses, this one doesn't have an x, so I can't factor out an x. But 6 and 2 are both divisible by 2. That'll be its greatest common factor. So now that we found the greatest common factor, we have to factor it out. That looks like this. Remember, whatever you factor out goes in front of parentheses, and then the parentheses is the leftovers. So x cubed divided by x squared, there's 1x left. 3x squared divided by x squared, it runs out of x's, so I just have the 3. Plus, this one I factored out a 2. 2x divided by 2, 2 divided by 2 is 1, so just 1x. Plus 6 divided by 2 is 3. And the important thing to note here, the thing that tells us we did this correctly, is that the leftover parentheses match. That is very important. If that isn't the case, you are not factoring by grouping correctly, or you just have a problem that can't be factored by grouping, which is possible. This last step might seem weird at first, but let me separate like this. That is now a term, and this is now a term. What do the terms have in common? They both have the same parentheses, x plus 3. So when I say factor out the common binomial, we can factor out the entire parentheses because they match exactly. So it's kind of a neat little trick that actually has a lot of uses in math. We're going to use it a lot this unit. Factor out the x plus 3, what we're left over with is going to be our answer. So x plus 3 is what we factored out. It goes in front, and then the leftovers go in parentheses. So x squared times the parentheses, well, the parentheses cancels out with itself. So there's just an x squared. 2 times the parentheses, same story. The parentheses cancel out, and there's just a 2 left over. So basically what happens is the parentheses are one of your factors in your solution. The stuff that was in front that you initially factored out is another factor. But that's it. that is factoring by grouping. We're going to do a handful more examples, but we're going to do this so much this unit, we're probably not going to practice it a lot on homework because it's going to be an involved step in every problem we do, so you'll get enough practice that way. Here's another example. Step 1 is to group the first two and the last two terms. Make sure to include that minus sign right here. That's to let us know that 12 is a negative 12. And then we got to factor out. So my numbers are 2 and 3. Those don't have any common factors. Then I have 3 z's and 1 z. I am able to take out 1 z. Now for the second parentheses, negative 12 and negative 8. 12 and 8 are both divisible by 4. So I'm going to factor out a negative 4. And then for the z's, the 8 doesn't have any z's, so I can't factor any out, so it's just the negative 4. What's left over is z, and then 3, we lose a z, 3z squared, plus 2, we lose the only z, so it's just 2, so 3z squared plus 2, plus, we factored out a negative 4, negative 12 divided by negative 4 is positive 3. We didn't take away any z's, so it's still z squared. And then negative 8 divided by negative 4 is positive 2. Our parentheses match, so we know we're good. Finally, we factor out the matching parentheses, and that becomes the thing in front. And the leftovers are the things that were in front of those parentheses, z plus negative 4, or z minus 4. There's another one. See, not too long of a process. If you aren't comfortable factoring out the greatest common factor yet, you need to see me for help. If you don't see me for help now, the rest of this unit is going to feel impossible for you. All right? So don't feel like, oh, I'll pick it up as I go. No, this is an important thing to make sure we can do and do consistently. This last problem is a great example of why we want to check one thing before factoring by grouping. That thing we want to check is it in standard form? Standard form is usually a pretty good bet. If I tried to factor this by grouping, why don't we do it real quick? We'll see that the s's just don't match up. There's going to be other issues too, but this first parentheses, 2 and 27 don't have common factors because 27 is an odd number. And then the 27 doesn't have any s's. So I can't actually factor anything out of this. So I'll factor out a 1, because you can always divide by 1. Over here, negative 18s and 3s squared. 18 and 3 are both divisible by 3. And I have 1s and 2 s's, so I can take out an s. Now let's see what comes out of it. 1, 2s cubed minus 27, plus 3s, negative 6 plus s. The parentheses don't match, which should tell us we know there's something wrong here. So let's fix this. The way we're going to fix it is by rewriting it in standard form. So I don't like these groupings. These groupings didn't work. In fact, grouping it this way will never work because the s's won't match up. So standard form is a safe bet. All right, so I'm going to rewrite this in standard form. 2s cubed is my biggest degree term, plus 3s squared minus 18s minus 27. And this reordering is enough to make factoring by grouping possible. Now I'll group them and see what I can divide out, and we'll see that they match up this time. So this has 3 s's and 2 s's. I can take out an s squared. 2 and 3 don't have any factors in common, though. Negative 18 and negative 27. 18 and 27 are both divisible by 9. I'm going to factor out a negative 9 because they're both negative, and this one's all positive. So I want what's left over to be positive stuff. Couldn't take out any s's because the 27 doesn't have an s. So let's see what it looks like. S squared, and then the leftovers. The 2 doesn't divide by anything, and I lose 2 of my s's. The 3 doesn't divide by anything, and I lose both of my s's. So it's 2s plus 3 left over. So 2s, not a 25. Let me make that obvious. Plus negative 9. Negative 18 divided by negative 9 is a positive 2. I didn't lose any s's. And then negative 27 divided by negative 9 is a positive 3. My parentheses match, so I know I'm good to go. Again, let's make sure that looks like an S. Factor out the common parentheses. I'm left with 2s plus 3. And then my stuff in front of parentheses, s squared plus negative 9, or s squared minus 9. All right, so we looked at a couple different examples that made us do some minor thinking, like this standard form idea, but this is basically what factor by grouping is. Any factor by grouping problem that's meant to work will never take more work than I'm showing here, and I'm showing every little piece of it.